Welcome to Module 7 of the NFPA13 training course, focusing on non-storage areas. This module is a critical part of your understanding as it moves beyond specialized storage occupancies to cover the sprinkler requirements for the vast majority of spaces within a building. We will be examining areas like offices, manufacturing floors, kitchens, and parking garages. The principles are foundational. The primary design factors we must always consider are consistent. First, the combustible loading, and which is the amount and type of flammable material present. Second, the continuity of the combustibles, meaning how a fire could spread between them. And finally, the overall building design itself, including its construction features and layout. Understanding these three factors is the first step in correctly applying the code requirements, and we will detail in the following training. This module will provide you with the knowledge to design and evaluate sprinkler systems for those common yet diverse non-storage occupancies. When designing sprinkler systems for non-storage areas, we base our decisions on three primary design factors. The first is the combustible loading. This refers to the total potential heat release from all flammable materials in the space, including furniture, contents, and even the building material themselves. The second factor is the continuity of the combustibles. Are they separated or are they continuous, allowing the fire to spread easily? A space within high continuity requires a more robust sprinkler response. The third factor is the building design. This includes ceiling height and construction, the presence of obstructions, and the overall compartmentation. These physical characteristics directly impact sprinkler performance. As you can see on the presentation, these factors apply to a wide range of occupancies, from corporate lobbies, cafeterias, manufacturing areas, and loading docks. Each of these spaces presents a unique combination of these three factors, which will guide us in selecting the appropriate sprinkler type, spacing, and location. Section 911 of NFPA 13 outlines the fundamental location requirements for sprinklers. The overarching rule is that the automatic sprinklers must be installed throughout the entire premises. Their placement is not arbitrary. They must be located so that no single sprinkler is expected to cover an area larger than its maximum listed protection area. Furthermore, they must be positioned to provide satisfactory performance, meaning their spray pattern must not be unduly obstructed. However, the code does allow for specific exceptions. Sprinklers are permitted to be omitted from certain areas, explicitly listed later in the standard. Additionally, deviations from standard clearance requirements between the sprinkler and the ceiling are permitted, but only when it is proven through testing or listing that such a deviation does not impair the sprinkler's ability to control or suppress the fire. This flexibility allows for innovative architectural designs while maintaining their life safety. In the next section of our presentation, the slide details the specific areas of NFPA 13 in sections 9.2 and 9.3, allows for the omission of sprinklers or provides special rules. It is crucial to understand that these are exceptions to the general rule of complete coverage. and must be applied precisely. The list includes concealed spaces within walls, floors, or ceilings under certain conditions, as well as draft-stopped exterior building features like canopies or marquees. These other areas are small, specific rooms, such as certain electrical equipment room, non-combustible stairways, elevator machine rooms, etc. This standard also addresses unique architectural features like revolving doors, cloud ceilings, and skylights. For each of these locations, the code provides detailed criteria that must be met for an omission to be compliant. This is not a blanket permission. The conditions for omission, such as limits on combustibility or size, are strict and must be verified for each individual case to ensure the overall fire safety of the building is not compromised. The topic of concealed spaces is so important that NFPA 13 dedicates significant guidance to it, starting in section 921. A concealed space is any building space that is not readily accessible or visible, such as the area above suspended ceiling, within a crawl space, or inside a soffit. The fundamental question is whether sprinklers are required in these spaces. The answer depends on several factors, primarily the combustibility of the construction materials within the space and whether the space contains any combustible material. For instance, a ceiling space formed by non-combustible materials and containing no combustible elements may not require sprinklers. However, if that same place is used for the storage of combustible materials or contains combustible wiring or similar, sprinklers are typically mandated. The annex material in A921 provides further helpful context for making these determinations. Building on previous subject, sections 9213 through 9215 and the annex note A921 provide more nuanced guidance for concealed spaces. The code considers factors like the use of the space for return air, which can spread smoke and fire. These areas are making sprinkler protection more critical. It also addresses the presence of combustible concealment, such as foam plastic insulation or wooden framing, which would automatically require sprinklers in most cases. The annex material is particularly valuable here, as it offers practical examples and explanations for the intent behind the code requirements. It helps designers and enforcers understand not just the what, but the why, ensuring that judgment calls are made with a full understanding of the fire dynamics at play in these hidden areas, which can often contribute to undetected fire spread. Section 922 and 923 provide requirements for exterior projections and overhangs, such as canopies, balconies, and marquees. These areas are potential fire hazards as they can be exposed to fire originating from inside the building, through windows, or from external sources. The key factor in determining sprinkler requirements is often whether these projections are draft stopped. Draft stopping requirements is often whether these often involves using the barriers to subdivide the space and prevent the free movement of air, smoke, and fire. Smaller draft stop projections may be exempt from sprinkler protection, while larger or open projections typically require sprinklers to protect both the structure itself and the area beneath it. Section 9234 gives specific rules for the installation of sprinklers in these exterior locations, considering factors like freezing potential and water discharge patterns related to these areas. Next, we are covering special rules for two specific occupancy types: dwelling units and hospital areas. In dwelling units, as per 924, there can be exceptions for very small bathrooms and closets where the fire load is deemed negligible, let's say. However, this should not be confused with a blanket exemption for all residential closets. For hospitals, Section 925 addresses specific closed closets in patient rooms. The code recognizes that these are typically small, limited in combustibles, and critical for patient care and movement. Therefore, under strict size and use conditions, sprinklers may be omitted from these specific closets. It is vital to consult the exact text of these sections, as the allowances are precise and come with strict limitations on dimensions and content to ensure life safety is not compromised as before. Section 926 provides the criteria for sprinkler protection in electrical rooms and similar equipment enclosures. A common misconception is that all electrical rooms can be left unsprinkled due to water and electricity risks. This is not the case. The code may permit the omission of sprinklers in dedicated, freestanding electrical equipment buildings or in specific small riser closets. However, for most main electrical rooms within a building, especially those containing critical high voltage equipment that poses a significant fire hazard, sprinklers are required. The decision is based on a risk assessment that weighs the fire hazard of the electrical equipment against the potential water damage. In many cases, the fire risk necessitates the sprinklers, and the use of listed electrical enclosures can help protect the equipment from accidental water discharge. Let's talk about the cloud ceilings now, which are defined in 3337. These are a modern architectural feature consisting of panels or sections of ceiling suspending away from the main ceiling, creating a floating or a cloud effect. Section 927 provides special installation rules for those features. The primary challenge is ensuring that sprinklers located above the cloud ceiling can activate promptly, that their spray can effectively reach the fire below. The code provides dimensional criteria illustrated in figure A92725. K dimensions include A, the minimum width of the cloud panel, and B, the maximum width of the open gap between the clouds. These rules ensure that that heat from a fire can readily travel up to the sprinklers and that the water spray is not overly obstructed by the cloud panels, maintaining the system performance. Sections 9.2.12 and 9.2.14 cover the rules for elevator hoistways, machine rooms, and other vertical shafts. These are critical pathways for the vertical spread of fire and smoke. The code generally requires sprinklers in elevator machine rooms due to the presence of electrical equipment and hydraulic fluids. For elevator hoistways, buildings exceeding certain height, but their installation must be carefully coordinated to avoid accidental discharge on elevator equipment to ensure they do not create a nuisance that takes the elevator out of service unnecessarily. Special escutcheons and shields are often used for the sprinklers. The goal is to control a fire that may start within the shaft or enter it from another floor. The requirements for stairways are addressed in sections 9 to 13 and 934. The need for sprinklers depends heavily on the combustibility of the stairway construction. Non-combustible stairways, such as those made of concrete or steel, may be exempt from sprinkler protection under specific conditions, typically when they are not used for storage and have no other significant combustible loading. However, combustible stairways, like those made of wood, always require sprinklers. Furthermore, even non-combustible stairways that are used for storage of combustible materials or are part of a required means of egress in a sprinkler building may still require protection. The code aims to prevent the stairway, a critical egress path, from becoming a chimney for fire and smoke. Section 9 to 16 through 9 to 18 provide a guidance for sprinkler placement near various ceiling features, most notably skylights. The primary concern with skylights and other sloped or raised ceiling sections is that they can obstruct the spray pattern of standard sprinklers or create pockets of heat that delay activation. The code specifies minimum distances that sprinklers must be located from these features to ensure an effective spray pattern reaches the entire floor area. This often requires additional sprinklers to be installed specifically to protect the areas directly beneath or adjacent to the skylight. Proper placement is essential to ensure that the sprinkler system's performance is not compromised by architectural design elements. Section 9.3.15 offers guidance on glazing, which refers to the use of large windows or glass walls. While glazing itself is non-combustible, it can significantly impact fire dynamics and sprinkler performance. In a fire, large panes of glass can fail early, introducing new air and potentially changing the fire's growth rate. This can affect the activation time of nearby sprinklers. The annex notes for this section often discuss the complex interactions between glass and sprinklers. The code does not typically mandate sprinklers specifically for glazing, but it requires designers to consider the presence of large glazed areas when determining sprinkler placement and spacing to ensure overall design remains effective. Section 9.4 moves from where to place sprinklers to which sprinklers to use. It covers the fundamental characteristics of the sprinklers themselves, their temperature sensitivity, and their orifice size, known as the K factor. The standard provides default selections to ensure effective performance. For temperature rating, the default is to use ordinary or intermediate temperature sprinklers in most settings. The K factor, which determines the amount of water discharge and the droplet size, has a typical minimum of K 5.6 for standard spray sprinklers. These defaults are based on decades of fire testing and experience, providing a reliable baseline for system design. Yes, the next slides expand on section 9.4 with critical detailed rules. While the default temperature rating is ordinary or intermediate, section 9.4.2.5 requires the use of higher temperature ratings in specific high heat environments, such as near furnaces or in attics. A crucial rule is that you cannot mix sprinklers in different temperature ratings within the same compartment, as this would lead to inconsistent activation times. The only common exception is for in-rack sprinklers in storage applications. Regarding K factors, while K5.6 is the typical minimum for general use, the standard allows for the use of other K factors such as K8 if they are specifically listed for the intended purpose or approved by the authority having jurisdiction, allowed for design flexibility. The next section is introducing the core principles of sprinkler location and spacing from section 9.5. The ultimate goal is complete coverage. Every square meter of the floor area must be protected. This is achieved by using standard formulas and adhering to strict maximums for the area covered by each sprinklers and for the distance between sprinklers from sprinklers to walls. These maximums are based on the sprinklers listed performance to ensure water density and adequate. Water density is adequate. This slide, the next slide, is also references sections 95533 and 95534, which provide guidance for more complex situations requiring supplemental sprinklers, such as in areas with obstructions or unusual geometries, to ensure no area is left unprotected. The next section, we transition into chapter 10 of NFPA13, which is dedicated to standard spray sprinkler installations. This chapter is one of the most frequently used in the entire standard, as it contains the prescriptive requirements for the most common type of sprinkler system across all occupancy hazard classifications. Chapter 10 provides the detailed tables for protection areas, spacing rules, and pipe sizing for light hazard, ordinary hazard, and extra hazard occupancies. It consolidates the fundamental installation criteria that form the basis for a vast majority of sprinkler system designs. Moving from the general principles of chapter 9 into specific actionable area. And in our final slide in this exercise training, there is a segment of table 9, table 10 to 421. A, which details the protection areas and maximum spacing for standard sprinklers in light hazard occupancies. This table is a perfect example of the application of chapter 10. Notice that while the maximum spacing between sprinklers remains constant at 50 feet, the maximum protection area per sprinkler varies significantly. It changes based on two K factors: the construction type, combustible versus non-combustible, and the presence of obstructions from exposed structural members. For example, a non-combustible unobstructed space allows 225 square feet per sprinkler, while a combustible space with closely spaced members reduces that area only to 130 square feet. This table must be carefully consulted for every design. Thank you for your understanding.